The nuclear fuel rods in a reactor like the ones that are in trouble in Japan are about 12 feet long. They are about 12 feet long. This is 12 feet long. And they are skinny. Calling them rods, actually, isn't exactly right because they're not solid. They're hollow. This one's made of cardboard so that I can hold it. But you can see. Can you see that it's hollow there? It's essentially a big straw. That's what they call these nuclear fuel rods. And these straws themselves, the real ones, are made of metal, a metal called zirconium. And inside the big metal straw, inside the zirconium, is uranium, the working part of the reactor, the part that makes it nuclear. When the reactor is working, the uranium pellets inside the fuel rods are creating fission. They are creating a nuclear reactor in order to generate heat. The whole point of nuclear power is that you create an environment in which fission happens. A nuclear chain reaction happens, but it's controlled so it does not produce an explosion. It just generates heat in a controllable way instead. You use that heat to essentially just boil water. Actually, you literally just use it to boil water. The boiling water makes steam, the steam spins a turbine, and that makes electricity. That's the whole basic idea behind these 40-year-old reactors in Japan that are in so much trouble right now. When the reactor is on, in effect, the uranium pellets inside those big 12-foot-long fuel rods are involved in a nuclear chain reaction generating heat. When they shut off the reactor, either in the normal course of events or because of something like an earthquake, they stop that nuclear reaction. Now, in order to stop the nuclear reaction, to do that, they move a bunch of control rods in among the fuel rods. The control rods stop the nuclear reaction from happening in an orderly way. I don't know if you ever had the chance to develop a photo in a real darkroom before everything went digital. You know how you put the photo, or you might have seen it in a movie, right? Somebody working with an actual, with actual film and actual developing chemicals in an actual darkroom. You put the photo in the developer until the image comes in the way you want it, and then once it's the way you want it, you put it in a different chemical bath to stop the developing. That's sort of like the control rods. They stop the nuclear chain reaction. But the fuel rods, those pellets of uranium inside those big metal straws, even when the reactor is turned off, they are still wicked hot. And so even though the reactor is off and it is not being used to boil water, to make steam, to spin turbines, to make electricity anymore, the fuel rods still have to stay underwater. Because if they are not underwater, they just get too hot to keep it together, to maintain their integrity. They start to melt. The first thing that happens is that the metal on those long metal tubes oxidizes. It essentially just rusts really, really fast. And as you know from what happens in normal life, when something rusts, it breaks down, right? It bubbles, it cracks, it splits. Damage to those fuel rods is a partial nuclear meltdown. One of the things that is released into the air as the water level drops and the fuel rods get exposed to the air and those big metal straws of the fuel rods start to oxidize, one of the gases produced is hydrogen, and hydrogen can be explosive. Authorities believe that hydrogen explosion is what caused this to happen at one of the Fukushima reactors on Friday night, East Coast time. It was daytime Saturday, Japan time. Then on Monday morning, Japan time, a second reactor at the same facility suffered what they say was the same type of hydrogen explosion. When we were told this weekend, after the first explosion at the Daiichi nuclear plant, that authorities had detected radioactive iodine and cesium in the atmosphere. Now, what did that mean? Why were they detecting radioactive elements in the atmosphere after that explosion? Well, those detections were an indication that the fuel rods had been damaged, and that let some of the radioactive elements in that nuclear fuel get released. And that is not good. As I say, a partial nuclear meltdown. It doesn't sound good, it is not good. But it is also not the same as a total nuclear meltdown, which they are still working to stave off. The explosions that happened at two reactors at the Daiichi nuclear plant in Fukushima on Saturday and on Monday, Japan time. These are explosions, and they happened at nuclear power plants, but these were not nuclear explosions. They were explosions that were caused by the inability to keep those fuel rods underwater and cool. The radioactivity released so far has been a sign that the fuel rods were damaged. The steam that's being vented, that's being let out into the atmosphere to avoid the pressure building up too high around the reactor, that is mildly radioactively contaminated steam, contaminated by the fuel rods being at least damaged, at least partially compromised. They have kept up efforts to try to submerge those fuel rods in seawater even after they knew they were damaged, because they're trying to prevent any further damage. As I said, what they think they've got is a partial meltdown, and that is bad. But what they are trying to avoid is an uncontrolled total meltdown, in which those fuel rods wouldn't just be damaged, they would break down totally. If that happens, the uranium inside those fuel rods slumps down into the bottom of the reactor, into what is essentially a big blob of radioactive lava, burning, I think, at several thousand degrees Fahrenheit. If that happens, if a total nuclear meltdown happens in a reactor, that pile of hot radioactive lava, that pile of hot radioactive goo, will burn through most everything around it. And we will be hoping that these last line of defense containment structures are actually capable of containing that melted fuel, keeping it from the outside world and from the Earth. Because if they are not, that would entail a much larger release of radioactivity. And that is not helpful for children or other living things. Tonight, just a couple of hours ago, we got word that a third explosion had been heard on site at the Fukushima plant. They have 3 reactors there that they have been worried about at Daiichi. 2 of them had hydrogen explosions on Saturday and early today, Japan time. Now it appears that the 3rd reactor they were worried about has suffered an explosion as well. The first 2 reactor explosions, authorities say, did not result in an unconstrained large radioactive release. Containment vessels had survived the blast. The main containment vessel around the reactor itself had survived the blast, even as other walls had been blown down. Well, tonight, reports from Japan indicate that the 3rd blast may be more serious than the first 2. It may have resulted in a breach of the internal containment vessel for the first time. May have. We do not have confirmation on that. It may have. Again, an explosion is not the same as a meltdown. An explosion at a nuclear reactor is not the same as a nuclear explosion. What's happened is that the inability to keep enough water circulating over these giant fuel rods, enough water to keep them cool, that has resulted in damaged nuclear fuel rods. And that has caused 3 explosions so far. And that has provided us with the only conceivable thing that could make the whole world look at devastation this horrible and think, we're as yet worried about something else. We're as yet worried about what might happen next, after this. Joining us now is David Lochbaum. He is a nuclear engineer, and he's the director of the Nuclear Safety Project of the Union of Concerned Scientists. Mr. Lochbaum, thanks very much for being here. I really appreciate your time.
Good afternoon. Good evening, Rachel.
Let me know first, I guess, if I got anything wrong there. If I got anything important wrong there, if I left anything important out. I am obviously a layman trying to understand this for myself as well as make it understandable for our viewers.
It was a very solid and accurate description of where we are today.
Okay. Within the last couple of hours, as I mentioned, a 3rd explosion was reported at Fukushima's number 2 reactor. Number 1 had an explosion this weekend. Number 3 did about 24 hours ago. And now number 2 has happened as well. Can we tell yet if this is a more consequential blast than the others, or is this likely to be of the same consequence?
The initial reports coming out of the facility are that this is the most severe explosion yet. The clearest sign of that seems to be that the pressure inside the containment structure on Unit 2 is decaying off, which suggests that some of the airspace or some of the volume inside containment is leaking out someplace, perhaps through a breach, perhaps through a crack, perhaps through a valve that's been left open. But if the containment were intact, the pressure inside would be maintaining constant and not decaying as it is, or reports show that the pressure is dropping.
In terms of that word containment, it's a word that we use commonly, not as jargon. It's meant in this case to mean a couple different types of structure, right? I mean, containment can be the outside building that surrounds the reactor as a whole. That was what we saw the explosions do so much damage to in the first 2 explosions. But containment also refers to the smaller containment around the core itself, around the reactor itself?
That's correct. These type of plants use defense in depth. There's actually 2 containment structures. There's the outer containment structure that was damaged by the explosions. That structure had completely surrounded the other containment structure, kind of like Russian dolls, containment within containment. The inner containment is called primary containment. It's 4 to 5 feet thick of concrete, reinforced concrete, with an inner steel liner of about 2 inches thick of steel to provide integrity against the release of radioactivity.
And it's that primary containment vessel that you're worried may have been compromised by this most recent blast.
The initial reports, hopefully, turn out not to be true, but the initial reports are that a part of the containment called the pressure suppression pool, or the torus, which is a big round metal donut-looking thing, has been compromised. We don't know yet whether it was by the third blast that the facility experienced or some other mechanism. Pressure is reported to be dropping from inside containment. That would suggest that gas is leaking out somewhere.
Forgive me if I get this question wrong or if I say this in an ignorant way, but as I have understood it, even after there have been these blasts at these other facilities, and that reflected some damage to the fuel rods. There had not been any sort of full meltdown of those facilities. And so even after those blasts, they've kept up the effort to cool those facilities down, to prevent any further damage to those fuel rods, any further meltdown. With the type of damage that you are worried about, that you're saying that this lack of pressure might indicate, does that mean that they will not be able to continue to cool this down, that they will not be able to essentially continue to work on this to try to make it more safe?
That's a good point, because if the containment is breached the way it's been suggested, not only can radioactivity escape through that pathway, but the seawater, the water that's being used to cool the reactor, could also leak out through that same crack or that same breach. If the leak rate, if water is leaking out faster than they can put it back in, then they're going to have a lot of trouble cooling that reactor core, and things may get worse before they get better. If, on the other hand, they're able to put water in faster than it leaks out through whatever pathway, they should be able to continue cooling the reactor down to a cold shutdown condition.
One last question for you. Authorities have evacuated some workers from Daiichi now. They say there are about 50 people left on site. If it turns out to have been if there turns out to have been a large radioactive leak with this most recent explosion, if it becomes too dangerous for people to work there, it's just too radioactive, is there a risk that they'll have to stop whatever they're doing to prevent further meltdowns? I mean, because these three troubled reactors are right next to each other.
That does pose a challenge. That came up in the Chernobyl accident. Chernobyl Unit 4 exploded, caused a lot of radiation to go over all over the areas. There were three other operating reactors that were very in the same proximity, like in Japan. The workers there were able to deal with the other three reactors. That widespread radiation at Chernobyl is worse than what we've seen or suggested so far at Japan. So it seems like the workers would be able to handle the other two units and even the stricken unit at Japan like they did in Chernobyl.
David Lochbaum, nuclear engineer and the director of the Nuclear Safety Project at the Union of Concerned Scientists. Thank you for helping us understand this, sir. This is a dramatic and bad night in this news, but I appreciate your time.
Thank you very much.
Thanks. There is a reason that in the English language, and particularly in American English, we use the word meltdown so often as a metaphor. That's because it always sounds like hyperbole. It always sounds like you are overstating the case, no matter what context you use that word in. But when we mean the word meltdown literally, it is worth being precise about it. It is not a good idea to let your imagination just run with this stuff. The facts are both understandable and, on nights like tonight, worth understanding. Please stay with us.